So I've got a little bit at the beginning just to sort of explain sort of who am I, why am I here? And this is one of my favorite graphs by Simon Wardley, and it sort of explains why I'm here. So this is the enterprise IT adoption curve, where enterprises ignore things for a while, then they say no, then they say, I said no, damn it, oh no, oh crap, I guess we got to do it. And then they catch up with the rest of the world. And so Netflix was a bit ahead of the rest of the world in doing cloud, and I had adopted this cloud unicorn icon a few years ago. So that's been my icon. And I was out there. I saw the rest of the world adopting things. And then we started to see the enterprise IT space adopting things. And so a little over a year ago, beginning of 2014, I moved to Battery Ventures. And it was really because when enterprises go through these major adoption phases, there is an enormous amount of sort of smoke, noise, confusion, money being spent, and new startups coming along, and old companies, falling by the wayside. So it's actually been a fascinating time to get involved in that, and I was well advised that this was good timing. So there's another thing that happened in 2014. At the beginning of 2014, really hardly anybody was talking about it, but by the end of 2014, basically microservices and Docker in particular is on everybody's roadmap. And there isn't a vendor or a cloud that doesn't have a Docker strategy already there, and there are products, and there's a whole lot of stuff. This came from nowhere. It's one of the fastest adoption curves anyone's ever seen in the tech space. So things that should have taken 2 years have happened in a few months. So that makes it much more fun as well. And one of the things I'm doing is just trying to figure out what the hell's going on in the Docker world. And about once a week, there's a blog post or an acquisition that changes it. So let me think. Last week was it 2 weeks ago was Socket Plane, and last week was the acquisition of something. There was some kite something. Anyway, I can't even keep up, and it's sort of my job to keep up. So I have no idea how you guys try and keep up. This is my main job, and there's a few things I'm doing today. Oh, hang on a minute. I thought sorry, a different slide. What I'm basically doing right now is presentations at conferences. I was visiting Fidelity earlier this week. It's an example of visiting companies when I'm in town. I was also on the program committee for this conference, so I didn't put a huge amount of contribution in, but I helped a little bit choosing things and in some of those discussions. I'll talk a bit at some point about this tinkering with technologies thing. I've written some code in Go that I think is interesting. My keynote tomorrow is me trying to explain why it's interesting and what I'm trying to do, but I'll mention it briefly today. And then networking with interesting people, and that is all of you people. So I'd be very happy, we've all said who you are, happy to get a connection on LinkedIn, which I don't process very effectively, but I get there in the end, or just talk to me on Twitter or email or something like that. So that's my main job. I mean, there's other stuff I do that's more sort of internal things. So I have a section I usually go through on the evolution of doing this kind of presentation. So how many people are really interested in the sort of how Netflix got to cloud story? That's usually, and how many people have seen me do this 3 or 4 times already and have had enough? Well, I think there's enough new people, so I'll go through this, try and be really quickly. So in 2008, we actually decided to do cloud on the back end of a really big embarrassing outage, which was basically the conclusion of the outage was we didn't know how to run data centers. And we could either try and fix that, or we could try and get somebody else to run all these machines for us. We had a whole data center full of snowflakes that were all configured slightly differently, and it was all just a big mess. And when things went wrong, one piece of storage hardware took out the entire site for 3 days. So 2008, we looked at trying to do it was a bit early. 2009, we started a process when the first thing we did was non-customer facing things. So we'd run out of capacity for encoding movies, so we moved that workload, which was like 100 machines in the corner of the data center. That wasn't enough. We got 1,000 machines in the cloud. I think a year or 2 later, it was 10,000 machines. So that was, there's a huge amount of just crunching through movies. The other thing that we did was around about 2007, 2008, Hadoop started to be a thing. And if you were paying attention and you lived in the Bay Area, you could go to the Hadoop meetups. And I think I have a 2008 Hadoop Summit shirt somewhere. And I hired somebody and he started playing with Hadoop, and we set up this, we found a bunch of old PCs that were lying around. I think they were Pentium somethings or there was almost no memory, almost no disk space, but no one was using these old machines because they were so slow. So we stacked 6 of them in a pile and built a Hadoop cluster out of it. And then later, people found it and they started running production code on it. And because they'd run out of capacity to do log analysis in the data center, and somebody had sort of figured out how to run Hadoop. So it sort of crept in on us. And we stuck yellow stickies all over them so people wouldn't power them down. But eventually we got some real hardware, and then that kept breaking. So we went, oh, screw this, let's go to Amazon. EMR had come out. So we said, Amazon, if you move to these versions of Hadoop and Hive and add all these extra features into your Hadoop distro, we'll just use it. And so Netflix was one of the early users of Amazon EMR and one of the drivers in terms of keeping it up to date with versions and keeping that team at Amazon sort of honest with sort of staying in sync with the rest of the Hadoop world. And I don't think anyone's ever stood up a Hadoop cluster other than asking EMR to do it at Netflix. So 2010, we actually started talking about what we'd been doing, and some people just, the conversation went on to, it's not going to work, you'll be back in your data centers pretty soon, a tail between your legs kind of thing. So the beginning of 2010 was the first pieces of Netflix, first simplest thing we could possibly find we put on the cloud. It was the search autocomplete. So when you start typing ratatouille, you type rat and it figures out how to spell ratatouille for you, right? There's no Chrome around it, there's no web page, it's just a web service, but it's invoked by the web page. And we could feed customers in and out of it on percentages. So we could go from 0 to 100% and back by just turning a knob in real time and redirecting traffic to this site. So that, however, we had an ELB, a load balancer, we had some services, we figured out how to deploy them, we had to upload search indexes to the cloud, which, infrequently. It wasn't a real-time sort of update system, but it needed an update every day to have the latest search index. So that was just the most primitive handcrafted shell script tooling you could think of to kind of get things going. So that was getting experience with sending live traffic to the cloud and switching traffic back and forth. So if you think about making architectural transitions, these are don't think about exactly what we did, think about the patterns. What's the simplest possible thing we could do that will teach us the most and retire a chunk of risk, right? What's the most risk and the most you can learn with the smallest effort? You do a bunch of projects like that, and eventually you build up confidence in things working. By the end of the year, we had the entire front end of the website running in the cloud and the API behind all the TV sets and games consoles and things. During that year, we knew we didn't have capacity to get through Christmas. We absolutely knew. Between Thanksgiving and the end of January, Netflix's capacity need roughly doubles. It's roughly flat for the rest of the year, and the reason for that is there's quite a bit of growth in customers during the summer, but the usage per customer drops off, particularly in North America, because it's sunny outside, right? So we know Netflix can tell very clearly when there's a snow day in Boston because the kids are at home, it looks like a weekend, there's traffic in the morning, the Nintendo 3DS has a lot of traffic to it, and the iPads have traffic to it. It's just you can just tell from the traffic curve when a substantial part of the population is at home, right? Weekends to weekdays, snow days versus regular days, summer versus winter. So there's this kind of fight between using it less per customer, and then when you get to the fall, you get a whole pile of customers coming in and everyone is using it more as well. So there's a double whammy and everything climbs like a rocket. So we had these pictures of aircraft running down the runway and either taking off into the nice pretty cloud or blowing up at the end of the runway. And we got to Christmas and just about got enough capacity left in the data center by moving almost everything out to run the few things that were still there. Well, there was still quite a bit there. 2011, people kind of finally agreed that we were doing something interesting. It looked like it scaled. And during 2011, there were some very big outages that Amazon had. And Netflix didn't go down, and that was a good thing for us, but basically said, okay, you have an architecture that looks like it can survive cloud outages, it scales, it's highly agile, but you're unique and no one else will ever figure out how to do anything like that. That was actually that was the accepted wisdom in 2011. What Netflix was doing in 2011 was moving the back end to the cloud because the outages we were having were almost all data center failures and network to the data center failures. And this is the year that we were really running what you may call hybrid cloud, right? And Netflix's idea, we had the plane crashing runway thing the previous year. This year, it was Roman riding. Was the picture that we had all year. We have to get, Roman riding is a rodeo trick where there are two horses doing tricks and there's one person controlling both horses and they've got a foot on the saddle of one, a foot on the saddle of the other, reins in one hand, reins in the other hand. The only thing holding these two horses together are your legs, right? And if the horses gallop around in perfect unison, everything's fine. One of them stumbles, one of them they go divert, you end up in a very uncomfortable pile on the floor, right? It's very embarrassing. So most of the outages this year were Roman riding failures. So we said we want to get off the data center horse and sit down on the cloud horse. And that would be much more comfortable, much more reliable, and that's what it turned out to be. So anyone that thinks that hybrid cloud is the end destination of their architecture and you haven't sort of really lived it yet, you'll find that it's relatively uncomfortable. There's now 3 things that can go wrong, possibly even 3 different vendors that you have to try and choke the throats of to try and work out what the hell's going on, right? When everything is in one place, you can actually manage it and control it much better. And then there are other ways of becoming highly available within that vendor. So 2012, people said, we like this, it looks good, we can't get there from here. So in 2012, Netflix started open sourcing aggressively, and I kind of led that program, got the idea, spread it around, showed some initial progress. There was some engineers pushing, and I started pulling, and between us, we got it going. And then I kind of rustled up all of the other pieces and said, if we get enough stuff out there, it won't just be a couple of open source projects, it'll be an entire architecture that people will be able to adopt. So that was the goal. So 2012, we actually put a lot of code out there so that people could copy us. And in 2013, I was doing roughly the same presentation, but the conversation was about different bits of it, Netflix OSS and how to use it. And there's much more discussion along that. In 2014, we're seeing sort of microservices come up, and in 2015, sort of Docker and microservices and this whole type of architecture. I mean, Netflix is sort of like a precursor in some way to what Docker has done and the microservices architecture. We didn't call it microservices in the first place. Any questions or comments or thoughts on this?
Just a quick question on the open source. Have you actually benefited? Certainly we've benefited from open source, but did Netflix benefit?
So the question is, did Netflix benefit from open source? There's a whole sort of hour-long presentation on that. The short summary is, if I can remember the 4 different ways, there's the most short-term goal for doing open source was to hire better engineers by providing, giving back to the community, to the Apache community in particular, because we were using open source and we were trying to fix things and change stuff. So that was really the first reason, was we were using this and we were trying to fix it and we wanted to give fixes back. So it was just like patches for Tomcat or whatever, right? The second reason was that we wanted to hire better engineers, and we wanted to hire the kind of engineers that had interesting open source projects on their name, and we wanted to develop engineers like that because people like people clumped together, and that worked very well. There's some extremely good engineers at Netflix who wouldn't have bothered to come to Netflix if we didn't have a major open source program. The third reason is one that I thought might happen, but turned out to be probably the biggest short-term benefit, which is if you ask an engineer to clean up their code, it's always at the bottom of the pile. If you ask an engineer to open source their code, there will be beautifully clean, documented, rewritten code. They'll work evenings, they'll work weekends, and their name is on that code on GitHub, and the peer pressure for that is huge, right? They want to be one of those engineers, and those engineers are worth more. And you have there's kind of 2 sides to this. You can play it a couple of different ways. I mean, an engineer with a really successful open source project is a substantially higher paid engineer than a regular engineer. Once the engineers figure that out, they want to add open projects. And you go, oh crap, now we have to pay them more. Well, you can pay them more, but also you can just let them leave because they carry on maintaining the code for you. Because it's now a major open source project, and if that was their main day job, then then that's happened several times. So that's kind of an odd way of thinking about it, that you can actually, if you build your software out of open source technologies, everyone else is writing code for you and fixing it. The final reason we wanted to open source was we knew we were ahead of the game, and we were trying to influence the rest of the industry to kind of do things in a similar way to us, so that we wouldn't end up in a cul-de-sac as this totally weird unicorn that was doing something different, and everybody else was doing something else. So we wanted to influence the industry to follow a pattern that was compatible with our future direction, so we wouldn't have to do one of those rebase to the mainstream things later because we'd got ahead of the market. You want to create fast followers so that you have kind of a feeling that you are going in the right direction. And from the technology point of view, we weren't concerned about, helping other people be fast followers, The unique value of Netflix is mostly in its original content and its in the sort of video streaming side of things rather than the platform that it runs on. So that was the way we thought about it. It's a great question though, and it's one that I didn't actually have a slide on, I think. Any other questions, comments? Yeah.
For companies that are just starting a migration to cloud, do you think it makes sense to just target public cloud and go heavy at that offbeat now, or do you still see a niche long-term for a hybrid cloud scenario?
So the question is, should you go straight for public or a niche for, or stay or target hybrid? If you're starting now, public cloud is way more mature than it was then. We were trying stuff out and breaking the elastic, and there was no IAM and there was no VPC. And most of the features you would use today to make this easy on AWS or any of the other cloud vendors weren't there. So we were making stuff up. It was much tougher. I think nowadays there's much less friction for putting stuff on public cloud. And the scale of things you can put there is far higher. It's like 2 orders of magnitude probably higher in terms of what you can successfully run on public cloud. So there isn't, and the other thing that I've noticed, and this really kind of got to me last year, I see little startups coming by saying, hey, we built a new thing. And I look at it and says, that looks like Amazon VPC to me, except you're doing it in a data center. Yeah. But we're doing the data center market version of it, right? And it's kind of crappy and doesn't quite have all the features of VPC. And then you do another vendor, we're kind of EBS in the data. And it started, there was a long line of companies that were Amazon features, but for the data center. And this isn't very innovative, right? And it finally realized that the data center is now trying to be as good as the cloud. And the really interesting, the most powerful architectures you can build are now on the public cloud vendors because they have so many features. They are so well organized. They have there's so much stuff there. And if you try and do that in your data center, you're cobbling things together and you're trying to solve this integration problem that's very hard. So maybe 5 years ago, data centers were clearly better than cloud. I think that's flipped in most cases now, and you're just more productive and there's more features and you can do more. It's more secure. The way IAM and roles and security groups and all that stuff ties together is very powerful if you use it right. And it's very locked down and everything's audited. So anyway, that's, but there are still people that will have stuff in data centers. There's specialized hardware needs. There's specialized, there's compliance needs. There's things like that. So it's going to be a while. But certainly the size at which it becomes worth doing cloud is, you have to do cloud is now getting bigger and bigger. I mean, you have to be sort of an Apple or a Facebook or one of the biggest banks really to have enough capacity to make it worth running your own stuff. That's my opinion anyway. Some of my people I work with are a bit more investing in companies to do private cloud at home, but it's okay. So I think there is definitely going to be a lot of private cloud investment over the next few years. It's not going to go away, but I just see that more and more people are going to find it easier to do public. All right, so I'll try and skip through this pretty quickly, but this is the basic idea of what we were trying to do at Netflix. We were trying to go faster than everyone else because that was our core advantage. Did that by taking friction out of product development, this high trust, low process, taking away the handoffs between teams, freedom, responsibility, culture, not doing our own undifferentiated heavy lifting, trying to get other vendors to do as much as possible so we could concentrate on the things that were unique to us. The approach to architecture was to find the simple patterns and then automate them, make them easy to use so that people would just adopt them rather than having this is the carrot approach rather than the stick approach to architecture. Instead of having an architecture review board and forcing people to use an architecture, we basically made it easy to do things in ways that made sense and made it relatively hard to do things that were more complicated or less likely to work. But it also let people innovate, and we kept adopting ideas that we saw happening in our effectively the end user community of developers within the group. And the other thing was to take these self-service clouds and do things that you would never dream of doing in the data center. So just because you can take this thing you did in the data center and do it a bit quicker in the cloud, that's fine. But now you've realized that the cloud is everywhere in the world, and you can create machines in Brazil as easily as you can create machines in Virginia. And that once you realize that, you go, oh, I have customers in Brazil. Let's put machines there and see what happens. Right? Oh, it didn't work because everyone in Brazil's routed via Miami to get to anywhere else, so forget it. So we actually did that. We ran some machines in Brazil for a few weeks, and you really do learn that basically South America's internet is a star network with a hub at Miami, in case you didn't know. So it turns out that to get from one ISP to another in Sao Paulo, you go via Miami in some cases, which is not really helpful. But anyway, so those were the kinds of experiments you could do. And there's like, okay, let's set up stuff in Brazil in a data center world. Okay, first hire a data center manager, argue with people. It's a year-long project to launch in a new country, right? It's a massive amount of work. It's 2 minutes work to launch an instance in Singapore, right, for anybody in the world, right? So that kind of freedom is amazingly powerful. So 2014, there's a nice Gartner analyst quote here for our friend from Gartner. Lydia Leong is one of the sort of really core people on tracking what's going on in cloud. So this was last October. She basically said, year on year, everyone's comfortably using public cloud, particularly AWS. The other one was the DevOps Enterprise Summit, which was last October. I was on the program committee for this, and we had 170 or 180 submissions, and we needed about 35 or 40 talks. And at some point, we were on the thing, and I think it may have been me that said it, but I basically said, let's throw out all the vendors and just have end users, just have end user stories, because we mostly had that already. So we just went through and got rid of all the vendor talks, other than vendors that were talking about their own internal use of DevOps, right? So there were a few people, the IBM and Pivotal were in there, but they were talking about how they did it internally, not about the products they wanted to sell. The vendors turned up and sat in the audience. They definitely were not going to miss this, because this was Nordstrom and Macy's and all people like that talking about how they did cloud. This is one of the best sources of internal company transformation, this whole enterprise reboot, over and over again. And the type of stories we got here, I'll sort of average together a whole lot of people. I mean, on average, people were finding that they were speeding up their development by an order of magnitude, and the best people were going by 2 orders of magnitude. So they were going from sort of roughly every 100 days you did a release to roughly every day you did a release, right? That's that sort of difference in release velocity. And then they were looking at the number of errors they had, and they went from sort of, you usually got over that 100 days, you actually had half as many errors as you did in that one big release. I've got some slides later where I try and explain this effect. But doing lots of little releases, you have fewer errors overall, fewer problems, fewer production failures than you do when you do fewer larger releases and with the monolith. And then the other thing they found was that if you do things this fast, actually it's a smaller team of people is what you need to do it, because there's less wastage, there's fewer meetings, and you get more done. And so it actually ends up costing less. So you end up having fewer outages and spending less money when you're concentrating on speed. And if you concentrate on cost, you end up quite often taking an overrun. When you concentrate on speed, you tend to underrun your budget. So there's one of these weird things where the thing you wanted you don't get if you concentrate on cost, right? The way to get to cost is to go so fast you don't have time to spend the money, in some sense, right? And it's kind of a bit weird, but Nordstrom was really just crystallized it. And they said that we went for IT ops, the department went from optimizing for delivery speed, from optimizing from cost to delivery speed. Yeah?
A question actually from the slide earlier, but I'm wondering, this might only be a problem in the educational world, but I know that in Canada, they've rejected some cloud-based educational enterprise systems because they have to run on Canadian servers, and in Mexico, I know there's a lot of distrust in running on
Yeah.
servers, and I don't know if that's...
Yeah, so this is a jurisdiction question, and yes, there is definitely, even when you could run on something that happens to be in another country, there are sometimes laws and things like that that force you to run in country, right? Like, I'm not sure, in the UK, I think there's laws that say you have to spend the money here, right? So they have to run on a cloud that's in the UK. So the UK government uses a cloud somewhere in London, right? Is that right? Yeah. So, that's the kind of thing you get. So last year, Amazon opened a cloud in Frankfurt, Germany. There are now German companies going, okay, you arrived, time for us to dive in and use it. Whereas previously, no, we're not doing cloud. So it makes a huge difference to be there. And what you find is that in most countries, there is at least one cloud. It's probably a VMware-based one. It's probably fairly small scale. And relative to something like Amazon, it's probably a multiple of the cost. If you look at the cost per hour per whatever. So what happens is there's lots of these little clouds, and then once AWS or Google or Azure turns up in that region, the cost of cloud suddenly drops by a huge chunk because you're now on a commodity cloud rather than a sort of an enterprise gold-plated with SANs in the back end kind of cloud, right? So that's what I'm seeing. Steve Brody said this was one of the best conferences I've been to. So go and find the videos. If you want to see the Department of Homeland Security talking about how they run the Netflix Chaos Monkey, which is seriously a thing, it's in there. That's one of the best talks. It was one of the keynotes. He said, I'm from the Department of Homeland Security. We're like, what the hell are you doing? Turns out they went from a year-long waterfall to an agile process. And the story of how they did that's amazing. All right. And talk a bit about disruption and how the difference between incumbents and disruptors, where you sort of, if you're going slowly, now you're an incumbent, and the disruptors are the people that figured out how to go fast. And one thing is another Simon Wardley point. If you follow him on Twitter, there is an endless stream of blog posts about this stuff. But his point is that you have to have a map to know if you're competing with somebody, and the strategy comes out of mapping. And most companies don't have maps. And one of his favorite stories is, I think we should bombard that hill. Why? Because 67% of successful generals bombard hills. And that's kind of the way that most business decisions end up being made. What he says is, well, I have this value chain. So at the top, I have the service I'm providing to my end users. And then there's a few novel things I have to build that don't exist. There's stuff in the middle that I'm going to buy as off-the-shelf products or SaaS services and things like that. And there's stuff on the right that's evolved to a commodity. And if it's a really big part of my cost, I might want to try and own it and optimize the hell out of its cost with a Six Sigma kind of process. But most of the time, you just buy that stuff off, like electricity out of the wall. So there's this agile in the middle, agile on the left, lean in the middle, and Six Sigma on the right. And once you've mapped everything out and you've got the evolution from Genesis to commodity, you get to figure out, the people doing Six Sigma should be doing Six Sigma, but not across the whole company. There's places where Six Sigma is exactly the right thing to do. And there's places where Agile is the right thing to do. And if you get that wrong, you end up confusing things and messing it up. So this is his sort of, they should have a 3-track. I think Gartner called this 2-track, keep the old stuff and do the new stuff. What Simon says is really 3 tracks, and the middle is actually the most important bit. Doing the lean part in the middle, if you take care of that, the Agile and the Six Sigma stuff will actually mostly take care of itself. So that was his most recent blog post. So go find this blog. Oops, pushed the wrong button here. Go find his blog. There's an enormous amount of content here. It's some of the most valuable sort of business strategy stuff that I've seen. So this is one of my favorite quotes. It isn't what you don't know that gets you into trouble, it's what you know that ain't so. It's the assumptions you made, it's the optimizations you made on top of those assumptions. And one of the big assumptions we make is that process prevents problems. If we have a release process and we push out a broken release, well, the right thing to do is to add a check into that release to not do that again, right? And then it takes a bit longer. Then you have more problems because you get more problems the longer you take. So that's a bit of an issue. And the problem is that organizations build up what I call scar tissue processes, which are basically, they consist of a collection of everything that ever went wrong arranged into a process. And you see laws of countries written that way. You see HR manuals, like if you're in a 200-year-old company, you have a really thick HR manual full of all the bad things that happened 100 years ago and 50 years ago, right? If you're in a brand new company, you have a very thin HR manual because no one's done anything bad yet. right? So think of it like that. I think one of the problems the US has right now is it's actually in this transition from being a young country with relatively fewer laws to this old country like Europe is with just way too many piles and piles of laws, and it's all very confusing and complicated. But we have a discussion over a beer or something about that. So if you're trying to dig yourself out and you're in one of these old-style companies, then this is one of the classic books, The Phoenix Project. So the whole DevOps Enterprise Summit came out of Gene Kim writing this book, taking it out to people getting excited about it, and that was really the genesis of an entire conference. It's a rewrite of this book, The Goal, which was about the theory of constraints from 30 years before. Most people on management training or MBA classes, at some point somebody will give you this book. Over the last 30 years. It's a really good book. It talks about manufacturing optimization and how to think about it and it's a novel about a guy whose factory is going to be shut down if he doesn't figure out how to save it. The Phoenix Project is a novel about an IT department that's going to be outsourced if they can't figure out how to actually deliver code properly. It's the same plot, right? Excellent book. At the DevOps Enterprise Summit, the guy from Target, and I forget his name temporarily, but he's actually got a blog now called something to do with goats. There's the DevOps Enterprise podcast. It's called Goat Up or something like that. Goatcast. Anyway, it's him and Michael Ducey, and they've got this podcast. Anyway, he said he bought, I think, 23 copies of the Phoenix Project, gave them to his management, gave them to his staff, discussed it at meetings, play-acted scenes from it at an offsite, okay? And that Target is now a very, very agile DevOps organization. They've got it figured out. But, that helped, right? So maybe you don't have to go quite that far, but ideas make a difference. And this is a novel. It's actually a horror story. Anyone that's ever worked in IT for any length of time will be wincing and going, my God, that was us, and have to put the book down a few times to go off and recover. So it's one of those. So product development processes have this problem, and they tend to look like this. You have a business need, and after weeks and weeks and weeks and jumping through all the hoops of the waterfall, maybe 9 months or a year later, the customer says, it sucks, I hate this thing, and then the team that originally specified it isn't even there. You have to start a brand new team from scratch to go and build version 2 of the product, and of course, the first guys were idiots, so they use a totally different technology stack, and they build something else that sucks. Right? So how many products are like that? A lot. So what you want to do is speed it up, and one way to speed it up is to actually just take out some of this hardware and approval piece in the middle and put an infrastructure cloud in. It sort of collapses this a bit, so that what you've got now is you go straight from your business need to software development, and you just grab some machines off a cloud, whether it's internal or external, and push it out. And this maybe you can get around in weeks. So you're sort of the Agile Scrum 2 to 4 week cycle that a lot of people probably regard as kind of normal now. If you're still on a quarterly release or annual release, you're kind of getting a bit into dinosaur territory. But a lot of people are in this space. Sorry, keep pushing. The buttons are the other way around to the way I'd expect them to be. So product manager deployment, QA, operations, and then some analytics to measure whether what you did was worth doing, and then go around the loop, right? So that's kind of a normal approach. It looks something like this. There's a whole bunch of cloud vendors that you could use to build it. That one's called Helion now. But there's this bit in the middle for deployment that you could replace with a platform. So if we get rid of that and put a PaaS in, then what we have is this, which is a sort of when you get to continuous delivery, you go down to one feature at a time. You don't bundle all your features together into a release. It's a single thing. It's the output usually of one engineer, and one product manager has an idea which gets broken into little chunks, the smallest possible chunk that you could deliver. The developer puts it out, and eventually, the feature reaches enough customers, you can measure its effects, and you feed that back. But in this case, the developer is working with a platform, and they're not having to do any meetings with operations. So, there's a bunch of tools that involved in this, Heroku, obviously, and all of these platforms. Netflix OSS is kind of a cloud platform for doing this at scale, and we'll talk a bit about that later. Let me see. Okay, Ericsson bought Apsera, and then I think Cask is a platform for doing analytics kind of thing. It's sort of a PaaS for analytics. But this bit in the middle, people build the same apps over and over again. So let's get rid of that and do SaaS, right? Where the business the sales rep configures his own Salesforce account. Okay, there was no developer involved in this. You just did it, right? So that's the kind of model here. And sometimes there's a bit more programming where you can get business people and train them how to build apps. Salesforce have some tools for doing that. Mendix is another company that has a kind of a platform for building SaaS applications. Platform is sort of the business analysts give them a platform for doing their own analytics. And there's thousands more vertical, specific SaaS things. But the point here is that if you get something wrong, you can change it, push a button, a few seconds later, it's done, right? So the whole thing is collapsed down. And that's one of the reasons SaaS has become really popular. This is the OODA Loop. So we're going observe, orient, decide, act, and trying to get around our continuous delivery loop here. So I'll just put this up. I've used this slide quite a lot, so hopefully some of you have seen it. But the idea here is that you're innovating, you're trying to find something to do. So maybe you saw a customer pain point. Your big data analytics are to try and figure out what to do about it and what the options are. And then your culture should let you do it, right? There shouldn't be an approval process that involves a vice president to make every little feature or fix. You just do it. JFDI means just do it. It's one of the managers at Sun always used to say that when you brought in some stupidly obvious thing. Just do it. Share the plans. You have to share what you're doing because somebody else may know, oh, that's duplicate to this. Or did you know about this? So it's very important to share what you're doing. In this model, very heavy sharing is key. But you're not asking for permission. You're sharing what you're doing, and you're looking for input, right? That's a different way of thinking about it. And then incremental features and automatic deployment is something that the good platforms will do for you. You just check code in, and it goes to production. So Heroku does that. The Netflix open source platform internally at Netflix is set up that way. And then you get to be careful about what you check in because it is going to production. So the system will check that it works. Then you get to measure customers and go around the loop. The key thing about this loop is that the faster you can move around this loop, the more you learn. And what you're learning is this is how customers behave and what they want. You're learning this is how markets behave, and you're learning what technologies work and which technologies have problems. And you can learn something every day. Whereas if you do a release every quarter or every year, you get one learning per year, and you have to spend a lot of time making sure you get it right. Here you can experiment and you can learn. And one of the things that Netflix is so fast at getting, I've seen startups, tiny startups go much slower than Netflix around this loop. They concentrated on getting all the friction out of it. So really complicated things are built extremely quickly.